Okay, moving on from what we were doing yesterday, in lesson 1.4, our learning goal has been I can solve equations, multi-step equations, so they require more than undoing of one operation to solve it. Well, today we're going to add to those. Sometimes you may have to simplify one side or both sides before solving. So what are the simplifying steps? We may have to do some distributive property. In other words, we might have some parentheses in which we cannot combine the terms that are in the parentheses. So we have to do the multiplication over those things, which helps us get rid of the parentheses. And another simplifying step that we'll look for is, are there any like terms that we can combine? So combine like terms. These are not solving steps. These are simplifying, getting it ready so that we can go about solving it. So we'll do some practice together here. We are going to solve 8x minus 21 minus 5x equals negative 15. This one does not have any parentheses in it. We don't have any distributive property to do. But it appears that we have some like terms. We have 8x and that subtraction of a 5x. They're on the same side of the equation. So we're going to combine them first of all. And then we can look at it and say, are we ready to solve it? So it's kind of like what we're going to do is we're going to look at this 8x and this subtract 5x, and we're going to say, just kind of ignore that subtract 21 for a moment and say we have 3 x's. 8x take away 5, we have 3 of them. And then we'll bring down the subtract 21 and the rest of our equation. So now we have 3x minus 21 equals negative 15. Is it now ready to solve? Or in other words, is there anything else we can do to either side to simplify it? No like terms on the left side, just a constant on the right side. I would say we are done simplifying. It is ready to solve. Let's put that in our notes. Ready to solve. Now is when we start showing what are we going to do to both sides of the equation in the process of getting the variable alone. So we're going to, our first move would be get rid of the constant on the left side. So we're going to add our 21 to both sides. And the result should be, these will cancel each other out. We'll have just the 3x left over on the left side. And now we have to determine what is negative 15 plus 21. I get 6. Hopefully you do too. And our next step, our last step, would be to divide both sides by what x is being multiplied by. We need to divide by 3. And we will find out that x, now alone, is equal to 6 divided by 3, which is 2. So we have our solution, x equals 2. Of course, to check this, where we would want to check it is all the way back in the beginning. Before we did any simplifying, we would want to check and see, does it make the equation true? So let's just do a check problem over here. Let's see. Let's double check to see if it would. We have 8x minus 21 minus 5x equals negative 15. The reason we have to check here is because we could have simplified it incorrectly, and then we get an answer that works for that, but not for the original where we started from. So we're going to say 8. We're going to substitute a 2 in for the x. Subtract 21. Substitute a 2 in for the x again. And we're not solving now, so we're not doing anything where what do we have to do to both sides thing. We're just evaluating. We need to evaluate that left side. So we have 16 when we take 8 times 2. We have 10 when we take 5 times 2. And now we will say, okay, 16 take away 21. That just so happens to be negative 5. Bring down our subtract 10 and our equals negative 15. Now we say, what is a negative 5? Take 10 more away from it. It is negative 15. Bring down our equals, bring down our negative 15, and we can say this problem checks because we got an equality, something that is true. So we're feeling pretty good about our answer. Okay, moving on to our second practice problem. As I suggested before, which I didn't have you do in number 1, but it definitely when we have distributive property to do, it is in our best interest to change subtraction to add the opposite. So the first thing we're going to do in this one is we are going to say, I'm going to rewrite this. That subtraction inside the parentheses, I'm going to make and add the opposite. So instead of subtracting d, we will be adding the opposite of d, which is negative d. So that's the only thing we're going to change in that step. Now we see that we have parentheses. We need to do distributive property. We need to do that multiplying. Take that negative 2 times both of the terms inside the parentheses to eliminate the parentheses. So we really have here, and I'm just going to show it in the notes, negative 2 times 3, bring down our plus sign, negative 2 times negative d, and we end up with equals 4. So negative 2 times 3, negative 6. Negative 2 times negative d, that becomes positive 2d, equals 4. We've been simplifying so far. Is there anything else we can do to simplify? In other words, now the parentheses are gone, no more distributive property to do. We look for like terms. Do not have any like terms on that left side, but negative 6 plus 2d, that algebraic expression, they are not like terms. So we are ready to solve this one. We have gotten it ready to solve. So now we can go about that. Our first move would be, we can read this one backwards. It's 2d plus negative 6. So we can see that, you know what, we're going to need to add 6. We add the opposite of what's being added to eliminate it. So we're going to add 6 to both sides. We're going to have a 2d left over on that left side because these guys are opposites. They cancel each other out. 4 plus 6 is 10. Our next move is going to be divide both sides by the 2 that d is being multiplied by. And we should have our d alone now. 10 divided by 2, 5. We believe the solution for this one is 5. But of course, we're going to check this out. We want to make sure. So let's do our check. Remember, we are always going to check in the original form of the equation before we simplified it. So we're going to substitute in, just for our d, what we solved d to be. We solved d to be 5. Now, we don't need to do distributive property this time, because remember, we're just evaluating. And 3 minus 5, we can actually do. So we're going to say we got this negative 2, and inside the parentheses, 3 take away 5 becomes negative 2. And we bring along our equals 4. And then we say, okay, what is negative 2 times negative 2? It is 4, not because we want it to be, for it to check out, but because it legitimately is, and the other side is 4, so we can say it does check out. We appear to have a good solution. Okay. Since I'm not here to answer any of your questions, hopefully you've just been able to follow along and you're taking good notes. Let's go to the back side. We have parentheses, so that's the first thing we'll deal with. We'll do our distributive property. We don't have any subtraction going on inside those parentheses, so we'll say, okay, looks like I can just go to work. We have 2 times x plus 2 times 2. We bring along our minus 4x equals 40. So what we're really, working on right here is we're taking care of those parentheses. Everything else looks the same. So that's going to become 2x. We'll just eliminate the multiplication dot there. That's going to become 4. And bring everything else along. Ready to solve? Nope, we got some like terms on the same side. When they're on the same side, we're going to combine them. So what we have here is we have this 2x right here and taking away a 4x. So 2x take away 4x, 2 take away 4 is negative 2. And they're x's, so they stay x's. We're just combining them. And bring our plus 4 along. Now I would say it is ready to solve, ready to go here. We've gotten it simplified to make the process actually easier. So we're going to solve our multi-step equation here. We're first going to get rid of that addition. We're going to subtract 4, which then leaves a negative 2x equals 40 take away 4. I get 36. We'll divide both sides by what x is being multiplied by. It's being multiplied by a negative 2, so that's what we need to divide by. X equals a positive divided by a negative is a negative. How many 2's can you take out of 36? Just so happens you can take 18 of them. Okay. So again, let's do a check problem. See how we did. We have a 2. In parentheses, we have an x plus 2. We have a subtract 4x equals 40. So we're going to put in our value for x that we got in both places. That's a 0, 40. Again, we don't have to do distributive property now though, because remember we're just evaluating here. We can take this, so we're going to have 2. We can take this, what's inside these parentheses, and add them together. Negative 18, add 2, well, we end up at negative 16. Oh, here's a good place to change to add the opposite. I'm going to take that subtraction here, and I'm going to make this an addition, and that 4 is going to become negative. So now I have that addition that's going to come down, and now I ask myself, what's a negative 4 times a negative 18? Well, a negative times a negative is a positive, and 4 times 18. If you can't do that without your calculator, you don't grab your calculator. Let's do it this way. Let's do 2 18s. 2 18s is 16, or excuse me, 2 18s is 36, but we have 4 of them, so what's 36 again? 36 plus 36 is 72. Remember, we're trying to keep our brains from turning to mush. 2 times a negative 16, a positive times a negative is a negative. 2 16s is 32. Plus, we bring down our 72 and our equals 40. We have a negative 32 at 72. So we have opposite signs. Whenever there are opposite signs, we say, okay, take their distances from 0. Negative 32 is 32 units from 0. 72 is 72 units from 0. Take the longer distance, subtract the shorter distance. 72 take away 32 is 40. Which distance is further? The 72's distance is further. That's a positive 72, so that makes this distance positive. And we legitimately have 40 equals 40. Yay, we have a Good answer, it appears. So again, when you're checking, I think sometimes that gets confusing for students. They end up trying to do the same kind of steps you're doing when you're solving. Checking is typically what's happening is you're evaluating one side. You keep working your way down until you have a value for that algebraic expression. And typically on the other side is a constant. So notice I said typically, not always, but that's the typical. Okay, let's do a problem that you're going to have something like this in your homework, and I want to make sure that I set you up for success for that. So it says, write and solve an equation to find the value of x in the triangle shown. So we have this triangle. It has an angle that's 35 degrees up there on the top. Down on the bottom right, that angle measures 57 degrees. And down in the bottom left, where it appears, it kind of looks like a right angle, but we have no idea. They say it's a 2x minus 4. They have an algebraic expression for it. So we need to set up an equation that will help us solve for, they want us to find the value of x. That's our goal. We always have to read that carefully also. They're not asking us to find the missing angle measure. They want x. So what do we know? We know that the sum of the angle measures in any triangle, doesn't matter what kind of triangle it is, we know that they add up to, the three of them together, add up to 180 degrees. That's prior knowledge. Well, that's useful prior knowledge. If we can set up an equation adding those three angle measures together and set it equal to 180, that should be a good start. So we're going to take that 35 and that 57 and that 2x minus 4, and we're going to add them, set up an addition problem, set equal to 180. Now, in this particular case, the parentheses that I put around that 2x minus 4 that were in the diagram, because we don't have to multiply that by anything and because we don't have to subtract it, because we get to just add it, in reality, those parentheses could just be ditched. So we'll do that in this next step while we're simplifying. We're going to add 35 and 57 together, first of all, and that will give us 92. And then we're just going to ditch those parentheses. So we're simplifying. But we're not done simplifying because we have some like terms. This 92, that constant, and subtract 4, the other constant, are on the same side. So we'll bring them together and say 92 take away 4 is 88. We have our plus 2x still over there. And now I would say that this is probably ready to solve. Ready to solve. No more simplifying necessary. So we go to work doing that. We're going to subtract 88, which gives us 2x on the left and 92 left over on the right side. We'll divide both sides by that 2 so that x can be a 1x instead of a 2x. And we're going to have x by itself now. And we're going to find out that x has a value of 46. 46. So let's just do a mental math check here. We know that if we double 46, because we just divided 92 by it to get it, we're going to get 92. So we're going to have 2 times 46 is 92. Take away 4 is 88 degrees. So if we add, so this became 88 degrees just now. So if we add 88 and we add 35 and we add 57, do those add up to 180 degrees? 8 plus 5 is 13, add 7 more is 20, 2 plus 8 is 10, plus 3 is 13, plus 5 is 18. Looks pretty good. But again, be really careful. Always make sure you go back and ask and double check what were they asking for. Were they asking for the missing angle measure, or were they asking for x? They were asking for x this time, so we are going to go with our circled answer right here, x equals 46. Okay, that's it for today. Time for you to get started on your homework. See you on Monday.